This is the Sustainable Goat Podcast.
We look to nature for how we should interrelate to the world. All the answers are within nature if we take the time to listen.
But what we have to find is a reasonable way how to handle plastic.
You know, consumers expect more. They're expecting brands to be more sustainable. They're choosing sustainable brands.
These are the stories and ideas from those that will define a generation. I'm your host, Steve Cassinim, and this is our planet in focus. I'm really excited about this conversation, just more about, the idea of electric flight and how much of an impact and how much of a change the flight industry usually is in aviation in general. So I'd love to just kind of learn a little bit about you. So you guys are based in Slovenia. Is that where you grew up?
Yes, I'm actually from the same town where Pipistrel is headquartered, Aidovština, Slovenia. You could say born and raised. Also, all of my education throughout to my PhD is in Slovenia. So I'm as local as it gets, I suppose. But then again, Slovenia is a nice place, nested in the middle of Europe, between Italy, Hungary, Austria in the north, and Croatia in the south. So we are at a relatively central location. It's easy traveling in and out of here. So I've seen quite a lot of the world, both courtesy of business travel as well as private. And I can say it's definitely the location where you can really foster innovation, lots of access to interested talents and people with a high motivational drive to show that also, let's say, the smaller players can definitely challenge the incumbents. We're not exactly known to foster the Silicon Valley spirit, as we are oriented more for the long run by, let's say, our values. And I think this also reflects in Pipistrel's story. Many people fail to, let's say, realize initially that the company itself had been founded more than 30 years ago. Yet again, then we come to most people's radars only in the last decades, having been busy with electric flight. But we've done very interesting things beforehand as well when it comes to aviation and providing affordability of flight and different flying machines, let's say, to people, and hopefully created spark in many youngsters that have then embarked on their professional journeys, either towards engineering or becoming airmen of sorts, pilots, maintainers, what have you.
Mm-hmm. Very, very cool. And where did the electric side come from? Where was kind of the thought process behind, let's try and do aviation differently? When did that process and conversation start? Because you guys were in it pretty early.
Yes. Pipistrel flew our first electric airplane. It was a 2-seater glider that we equipped with an electric powertrain back in 2007. So we started actually working on this project a few years before. 2005 is kind of a fair time frame to say that we actually started contemplating it. It comes as a confluence of the company's original vision as well as technological availability. But it was very, very small and very modest availability comparing to what you have now. So the company was essentially set up to cater affordable flight and minimize the energy spent when you fly. So gliders were Pipistrel's first products. And, glider pilots really hate engines. But what they really appreciate is to be able to go gliding and enjoy this essentially energy-free form of flying, right? You really are embracing Mother Nature's powers and thermals and lift to keep flying and cover the distance and have fun if you wish. The idea of motorized or self-launching gliders caught on in the late 1990s and the early 2000s. And these machines were equipped with the lightest gasoline engines possible. They were 2-stroke engines. So think chainsaw or jet ski-like engines, quite noisy, not very fuel efficient. But at the other side, they were only used for a few minutes during the glider's takeoff and climb. And then they were essentially useless weight, but they've done their job. And, at that time, Toyota was coming out with Prius's large success. The batteries have picked up with their performance. We started using more and more elaborate mobile devices, laptops, phones, the internet era was really starting to flourish. So one thing led to another, and the spark came to, hey, can we perhaps swap out the notorious two-stroke chainsaw-like engine for something far more elegant, quiet, I'd say not really burdening the environment, but actually still providing for what glider pilots really wanted. And that was flying with no noise and no emissions, and also essentially creating a carefree experience for the pilot. Glider pilots are not trained to handle engines. As part of the training syllabus, actually, this thing is not there. And there were, and still are, unfortunately, quite many accidents that happen on the account of glider pilots becoming distracted with handling of these engines. Like, I don't know, getting low on altitude, no more thermal activity, trying to restart the engine, engine doesn't start, chainsaw again. Mm-hmm. Whereas the employment of the electric engine changed all that. The electric engines are incredibly reliable. They start up at a push of a button. The complete startup sequence in our case, already with the prototype aeroplane, was completely automated. So there was one button you pressed, the engine came out of the aircraft's fuselage, propeller started turning, and off you were climbing again. And it was accepted extremely well. Now, of course, what these first steps did not cater was for speed and range, which is kind of what you always want to build in an aircraft, especially if you want to create a family of them. So at that point, the frontier was kind of flying about 100 kilometers an hour, 50, 60 miles an hour for 20 minutes or so. So that was the frontier of technology when Pipistrel started. And it only took 5 years or so to stretch this to almost 3 hours and upwards of 200 miles. So the pace of development was tremendous. Now, none of these two attempts, so the 2007 motor glider prototype flying, and then the 2011 four-seater, which we raced at a NASA competition, none of them were products immediately, but each of them brought elements which later found themselves into what Pipistrel today delivers to customers. And for the time being, we are still the only aircraft manufacturer that delivers electric aircraft, still the motor glider, now in its third generation, as well as the trainers and aircraft that you can use commercially that are electric. So I think we've come a long way in more or less 15 years of us looking into these fields.
That's an absolute incredible story. Because the challenge of electric is kind of difficult. So we've had a yacht company on the podcast, and it's an electric yacht company out of the Netherlands. And they said one of the biggest challenges that they had was you can increase propulsion and battery and range, but you're also increasing displacement because you're adding more weight. Mm-hmm. And so you're always chasing your tail, and there's a certain kind of limit, if you will, to battery. What was that challenge like for you guys as you were trying to take on flight?
So obviously there's two enemies where it comes to employing any technology into flying that are obvious to anyone in connotation with flight. And one of them is weight, and the other one is safety. But here, this only proved to be 2 out of the 3 elements that needed to be tackled. That's why I say that they are obvious, and the third one kind of wasn't. So in terms of the batteries, we still today make our own batteries, and we will continue to keep that as our core expertise in the way that we purchase battery cells, which we are able to source straight from the manufacturers, and oftentimes they are specific production runs for Pipistrel, featuring some either safety enhancements or chemistry adjustments. So we have the luxury of doing that, but we do not produce our own chemistries in-house. We're not a chemical maker. But once we obtain the cell, we build the entire pack around it. All of its mechanics, cooling, safety provisions, battery management, electronics, oversight, all of it. This means that we are intrinsically bound to the rest of the industry or industries that also take batteries as their input material as to how good of the battery we can produce, right? So there's no such thing where in reality, where one walks out to, hey, dear battery cell manufacturer, I want something that's 2x better in this regard, and they would happily cook it up just for you. You need economy of scale to make it commercially viable. So we worked on the battery in particular on the safety side of things, learning a lot how batteries behave in nominal and off nominal condition. And let's face it, in aviation, the usage profiles of a battery are just different than somewhere else. Maybe just as an illustration, in a car, everybody is really fond of acceleration that electric cars cater. That's one of the emotive situations that happens when people first experience a ride in an electric vehicle. But that high power regime that the battery is subjected to during an acceleration of an electric car is maybe 10 seconds. If it's a bad electric car, maybe 3 seconds if it's a good electric car, but that's it. Right? Imagine an aircraft has to sustain such power loading for minutes at a time to essentially support the needs of a takeoff, a climb out, and maybe also situations where pilots need to kind of take themselves out of a more dire situation around weather, go around when the runway maybe is blocked by something. There's situations where battery really works and sweats. So learning about not only the safety aspect, but also how to drive the longevity of the batteries, because let's face it, economics matter. And when you do it right, there's clear advantages when you go electric in aviation also. There's clear advantages in operating cost, but not if you don't have an understanding what really hurts the battery's life. So the initial focus was there. There was then an intermediate period where, especially for aviation, people started to be absolutely evangelistic about the power density, meaning can you introduce ever lighter components as if this was the recipe for, let's say, better overall products on an airplane, like longer flights, faster flights. But it turns out that this is only part of the equation, because what is the non-obvious component of the whole journey is the efficiency of the overall energy conversion. So how much of the energy you actually carry at the moment of takeoff you can employ in motive force. So the more elements in the chain you have between the battery and your propeller, if you wish, or whatever creates thrust in your aircraft, the more opportunities you have to lose a small part of your energy. So an inefficiency on top of an inefficiency on top of an inefficiency can create a situation where your battery can be tremendously good in the, let's say, panoramic view of all batteries, and your electric motor can be incredibly lightweight in the context of all electric motors out there, yet you've not created anything meaningful in form of the complete aeroplane, because this chain of efficiencies or inefficiencies might have gone the wrong way. So this is what we spent a lot of time in. The motor glider perhaps is a very interesting example of that. From the original 20 minutes I spoke about, those 20 minutes converted back in 2007 to the ability of climbing to around 3,000 feet, 1,000 meters above the starting point. So think takeoff, and the battery back then got you 3,000 feet higher than when you began. Now it gets you almost 9,000 feet higher.
Wow.
Yet the battery did not come to be 3 times better than 15 years ago. But every little thing contributes. So we have better power conversions, like more efficient power controllers, better cabling, better understanding in cooling principles. A lot of it is in control algorithms, like how precisely you can control the rotation of your motors. And slowly but surely, as the knowledge builds up, right, you are able to essentially weed out these effects that previously were not considered as meaningful, yet they truly are. So we continuously improve that. And it's no different with our pilot trainer program. On the charging side of things, right, even throughout last year alone, we managed to drop the charge time by about 10 minutes, which is 15%, let's say, of an improvement, only on the account of having a better understanding what the battery can tolerate without degrading its life or safety. So as more knowledge is available, the same product continues to bring more value to the user, right, in one key aspect or another. So I think the overarching situation, especially when it comes to electric aircraft, is that they will only become better, and not by adding new components or by replacing something vital, but also by just the way they are being handled, or how much you can streamline and optimize every little let's say, function on the aircraft that you already have by making it a tiny percentage better, yet it adds up in the end.
Mm-hmm. Well, and at the same time, you have this challenge in electric of range to kind of match. And it was kind of the same in automotive, is how far can the electric vehicle travel versus the petrol or gas powered vehicle. And when that overlap happens, which I think has kind of happened in aviation in a way, in terms of the short flight stuff, how do you think this scales into something bigger? I mean, do you see a future, I know maybe not for Pipistrel, but do you see a future for fully electric flight of just travel?
I would say absolutely so. I think the important notion when one spells out the term electric flight is to have an understanding that this might not need that all of the energy for flying comes from a battery. I don't think a battery equipped airplane when you hear electric flight. It means that somewhere on the airplane where power needs to get from A to B, electricity is used instead of mechanics. And this opens tremendous opportunities. I mean, the reason why we see aircraft look like the way they do today, regardless whether this is a small Cessna or a jet trainer or your A350 or a Boeing 777, it's because engines are large and heavy. So you only have some limited opportunities where you actually put them on the aircraft so that the aircraft is in balance, so that you don't jeopardize, let's say, the volume for passengers and the payload and so on. Now, electric motors are 10 times more dense for what they are powerful towards the conventional ones. So all of a sudden, they become much smaller for the same power. You can start putting them on interesting places like towards the end of the wing or on the tail, or, and this really changes the drag profile of the aircraft. So you really start having these advantages there, not because you're using a more efficient powertrain, but because your airframe has become more efficient. The marriage between the powertrain and the airframe alone constitutes many opportunities. Battery on its own is not the silver bullet. It is only the most simple and elegant embodiment of the term electric flight. There's least energy conversions, going from electrons in a battery to electrons creating motion in an electric motor and thrust by a prop or a turbine or something different. So it is going to remain most likely the most cost-effective and energy-efficient method. So it totally makes sense to deploy it where people fly the most. And it turns out that 80% of the flights are actually relatively short. They're not your cross-oceanic flights. They're more regional than you might think, actually. For the longer flights, and currently I would say that anything longer than 4 hours or so is almost certainly poised not to be facilitated with battery power alone, ever, just because of how the battery weight relates to the size of the airplane. You gave a great example with boats. Yeah, I mean, you can keep on adding weight, but you're also getting heavier, and thereby you start requiring more power to move at all. So you didn't do much in the end. Same with aeroplanes. But it's topics such as hydrogen fuel cells, which really are onboard converters from your fuel, which is hydrogen in this case, to electricity, which is then used on board the aircraft in the same way as if you were using a battery. It just runs the airplane for a much longer time. And there's other possibilities as well. I think one needs to really appreciate electric flight as such, as an enabler for different aircraft architectures, but also different energy sources. It may be a battery, it may be your fuel cell using hydrogen, it may be something totally different, but just the sheer design space that's opening up now that you use smaller electric motors that you can put into different locations on the aircraft, improving the design overall, holistically, is a big promise. Why I would almost be certain today that electric flight is our inevitable future. And after all, I think we all have to ask ourselves, what do we want the next generation to remember us for? To just keep on pushing incremental changes and focusing on short-term developments, or really kind of embracing a tough challenge, but with an incredible long-term promise for humanity, for the way we travel. I mean, the sheer ability of humankind to travel has created or enabled more knowledge onboarding and acquisition than anything else before.
Yeah. I mean, it definitely pushes the world forward and connects the world and has shaped it. And, when flight became something where you could just fly across to Europe, that changed the world.
Yeah.
And now we're kind of at that point where we can change our mobility the way that we do it, from cars to boats to aircraft to everything. And I think it's interesting.
I think I'd like to add here that traditionally one might have thought about aviation of a means of travel, transportation that is enabling to fly farther. But it might also be the enabler of, let's say, a totally new service in terms of mobility that starts to quicken our shorter mobility needs. So it may not be only the let's try and beat the traffic jam or the gridlock situation, but it could also be very interesting daily commute, say, opportunity. It just has the chance of diversifying or changing the quality of life, because now maybe you don't need to live at the perimeter of the city. Maybe it's the same if you live 100 miles out, because now you have a tool that brings you into where you need to be on demand with the same economics as what you do with a car today. It won't happen tomorrow, but unless it is tackled, it may happen never. So it's important to give aviation the chance, not only on the long distance high speed, but also on the shorter distance, but incredibly affordable flying opportunities.
I think it's interesting you mentioned that, because when you think about that concept, you have the opportunity also for an infrastructure change too, because realistically with electric motors, your acceleration's faster. So you get up to speed faster, which means you take off faster, which means runway lengths go a little bit shorter. Yeah. So you can make more neighborhood airports, if you will, where you can actually land your commuter.
So here at Pipistrel, we love a term that we started putting out there, and we call it community-friendly aviation. We see with our current product offerings, although they are 2-seat and 4-seat aircraft, electric and hybrid, that they have an incredible impact on the noise the aircraft create. So there is a reason why airports are where they are today, because people have just found aviation to be an annoyance over time, for sure. Imagine if you have a much quieter aircraft, perhaps not a 200-seater, maybe not even a 100-seater, but maybe a 20 or a 30-seater. What this could do, reactivating the airports that actually are closer to communities, but are not being served with regular operations, because airlines of today know, should they attempt that, they would go into very strong pushback relatively quickly by the communities. Now, a dream aircraft is, of course, such that can fly 24/7, 365. And does not create annoyance. So you basically should not notice when it even comes or goes. And electric is going into the direction of this statement. Yeah? So it is an enabler, but it's also been proven in practice that with electric airplanes, let's say our Velis Electro now operates in locations where they have previously absolutely prohibited flight training, because pilot training is a lot about practicing takeoff and landings, and the aircraft continuously, climbs, descends, comes, goes, and creates annoyance. Not so anymore. So we have now operators which were able to successfully reactivate existing infrastructure, and they're getting many more student pilots just because of their proximity to where people live. No longer you have to take a half an hour drive to somewhere just not to annoy anyone when you take pilot lessons. You're just doing it literally next door. And we can definitely see this trend continuing beyond pilot training and what's possible today with economically attractive electric flight. But in the future, this will definitely create a wave of different mobility opportunities and solutions.
Yeah, 100%. And even when it gets into the design of the aircraft as well. I like that you mentioned the idea of you can place batteries and weight in different areas than you used to be able to. Have you guys experienced with that in terms of your aircraft design? Because it does open doors to, you could literally change what an aircraft looks like.
Yes. So Pipistrel essentially has two kind of trajectories when it comes to electric flight. One of them is what we would call the type certified trajectory. It's aircraft for mainstream use. They come with all certifications in place so that they can be used as any other airplane out there And our mission for the time being is pilot training. So they kind of have to be similar to other trainers, because it's no help if you kind of create a new generation of pilots that are only safe flying one very exotic new type of an airplane, and they cannot easily transition to other types, right? I mean, then we kind of did it wrong. So those aircraft are intentionally close in look and feel to what you would expect, right? They are kind of a continuation of the known, yet with a new engine. So they are not built up to be electric aircraft only. So typically they would use an airframe that has existed before, like wings, tubes, and so on, and employ an electric powertrain. So not an optimal solution, but optimal for what they are being used at. And then we have the research direction, where we had hybrid cases. We had flying on hydrogen with different partnerships in place. And those aircraft were conceived to only be electric, right? And they do look and feel more exotic, and they may be an indicator for how the aircraft shape will look at. So I think we are nearing the point where we will start seeing aircraft that holistically, so not only the powertrain, but everything on it, the shape, where the powertrain is, where the battery is, where the props are the way they are because the aircraft is electric, and there's no way back. Once you take this big leap into, hey, let's reinvent the whole airplane, and let's not just put an electric powertrain on something that we know and works. This is when it becomes really, really interesting. And we are basically at this point in time where we can confidently take this step.
That's amazing. And do you think it's, I don't know, too early, if you will, for the public to accept a completely different looking aircraft? Or do you think, because sometimes when automotive companies release prototype designs, everybody loves them, but they're so far out there that production, it wouldn't make sense. Where do you think that is with aviation?
So public acceptance is a big deal. It's something that Pipistrel invested a lot of effort in the last 15 years, obviously. And it goes hand in hand with education. You cannot just expect people to embrace something if they don't understand it. And it's key that many, many stakeholders are involved in gaining an understanding that something that looks new and exotic and, just different, let's say, is embraced. Until people understand not only the benefits, because marketing is something that most people take with disbelief, like take a look at baby diaper commercials. They keep claiming that all of them are dry, and how it is. So it's easy to claim something. The other point is, do people actually take it, embrace it, and in an essence, become your extended outreach? So the aviation community will have to do that, and maybe also through the regulators. But I think the key element of this is demonstration. So it's actually showcasing, bringing things amongst the people, getting them an opportunity to experience all this firsthand. There's nothing more valuable than, being able to touch, feel, experience. And this always goes from small to large if you don't want it to be daunting. So we take our role in this, let's say, metamorphosis of the aviation industry very seriously from this standpoint as well, because in this, let's say, nation period, it would only take one event to send the wrong message to the crowd. So I think it's really key to be open and transparent and not only speak about the greatness, but also speak about the challenges, because every great story in life has its own heroic moments as well. So if it seems too easy, it's probably too good to be true. And this is not easy, and we're not promising the moon tomorrow, but it definitely stands a promise that can really drive the change. But it's only through education and demonstration. These are the most powerful two elements one can add to the sheer fact of, let's say, unveiling that there's something new and exotic out there.
Yeah, I totally agree with that. And I love that you mentioned that you guys are on a journey, and it's always to kind of improve, and there are ups and downs, because that's life, that's a business, that's trying to invent something new. That's oftentimes the journey of it. I think it was Thomas Edison, I think, said that he found out 999 ways a light bulb didn't work, rather than finding the one way that did. So
I think showing that something is real is also not pretending that everything is just shiny, and there's also real challenges associated. But making an effort, right, really to do the absolute best you can to understand and work around or work for that. I mean, it's, if you take a look at just cars as we've had them for pretty much all the time until 5 years ago, nobody even questioned themselves that there's like an explosive liquid being pumped underneath the seats. And when it enters the front compartment, there's like thousands of explosions per minute happening. And this is what makes the car go. And if you look at just like on a micro scale what it is, it can be scary very quickly. Yet, because we have an understanding of it, we accept it. And on the other hand, if you look at the hairdryer situation, nobody thinks about, hey, would a gasoline-powered hairdryer perhaps be better? Just because, no, where again, it's the knowledge and the education which sends a clear no. But if you ask the same question 100 years ago, maybe the answer wouldn't have been that clear, right?
Mm-hmm. And then when it comes to material science, so that part is kind of a really exciting frontier in terms of pretty much any facet of business, innovation, mobility. I mean, material science is huge right now. Are there materials that you can explore to actually construct the aircraft with?
So let's say when you electrify an aircraft, there's added challenges. They are associated with cooling or heat rejection. They are associated with high energy discharge. So if you have, let's say, a battery cell rupture because of a manufacturing defect 10 years into the usage cycle of the aircraft, you better be able to handle it. So high temperature materials, obviously everything has to be lightweight, but also what about electric conductivity? So like you want to keep your high voltage away from people. Obviously you want to be able to do that in event of an accident as well, when the structure starts mangling and all that. So material science is a big deal. Now, what drives us forward is not only the materials that kind of address failure modes or let's say phenomenons that can create a bad outcome, injuries, fires, damage to different aircraft elements. We are looking at an electric aircraft from the complete energy spent that goes into creating it, but also goes into recycling it. There's a big notion of, hey, what's the battery's second life opportunity? So once they are not good anymore to fly, can we use them for something else? And when they are completely useless for any kind of, let's say, meaningful application, how do you best recycle them? What do you do with the materials? So we also look at the rest of the aeroplane like this. So how about the load-bearing structure? Is there materials that are more eco-friendly? Can you contemplate a situation where, 30 years down the road, you kind of melt your airplane and you create a new one from the puddle that's been left over by cleaning it up, adding it. So the whole notion of circularity of technology has really been triggered by the electrification. So you see it in automotive. Let's say it's cleverly disguised sometimes. Vegan leathers, different panels that are composite. It's not only in the direction of going lighter weight, it's also in the direction of circularity. So what's kind of the best material usage to achieve the function people like to see, but also not to burden the environment? Because let's face it, there's just certain materials which are easy to come by, but they're not as easy to dispose. So I'm happy that there's more and more discussions revolving around looking at the aeroplane as a whole and what you can do with it once it's no longer an aeroplane, and how you should handle that throughout its life cycle and after.
So how did that thought process make its way into Pipistrel of just, how can we best be conscious of the planet and the circularity of everything that goes into it?
So gliding, just as well as sailing, right? It's kind of a very pure way of moving around. It doesn't essentially create an opportunity to go fly whenever you want, whenever you want, just because the weather doesn't cooperate, right? And you have dependencies on other things. But it does teach you that the best energy is the one you never use. Let's say when you are in gliding weather with very weak thermal conditions, you basically have to try harder as a pilot to even stay up, right? So you should not waste your energy. You should fly carefully. You should not do unnecessarily movements with the airplane, because that all creates a worse situation than what you began with. So with Pipistrel, we really embodied this every step of the way. More than a decade ago, we became net energy positive, photovoltaics on the roof, create our own electricity, to kind of offset for the materials that we still use on the aircraft that are not as easily recyclable like the composites of today. There's simply certain things that you cannot easily go around because of certification requirements. And in aviation, safety is obviously key, but the notion of safety is derived through enough experience. It's very difficult to showcase and prove and constitute a safety case for something that's not been used for a few years, maybe a few decades, before you put it in the hands of your own customers. So even if somebody came with the magically sustainable material today, it's not feasible to employ it on an aviation product of tomorrow, just because there's not enough knowledge revolved around it. You better start 20 years ago so that you can do it tomorrow. That's just how aviation is, and rightfully so. A very similar thing in pharmaceuticals, right? So it takes time and an incredible understanding of when is a good moment of actually deploying something that has a lot of potential, but you just don't know of all the possible side effects until you've researched it enough. And aviation is very similar in this regard. So we are trying to pull levers in places that are not the aircraft, right, to essentially create as sustainable as possible the complete operation and the life cycle of the aircraft. Historically, we were one of the first that were able to use non-aviation fuel, so automotive-grade fuel with E10 on our aircraft. So even the ones that are not electric are more environmentally friendly than your, let's say, conventional fuel-driven aircraft. So there's things we do on many fronts. But all in all, this is all enabled by, I would say, extreme aerodynamic efficiency, right? Cleaning up the aircraft, making sure it's able to fly with the absolute minimum of the energy requirement that you possibly can. And this, let's face it, was the key enabler for us looking into electrification, because batteries were not good enough. They're still not good enough. Yet, if we have a good starting point, it can be done. Yeah, it absolutely can be done. But not every aircraft is feasible as a launch pad for electrification. Some of them are just, let's say, too energy intense, or let's say too draggy to be feasible as an electric aircraft.
And what's your favorite part of working at Pipistrel and just the whole process?
For me, it's literally the ability of pulling in solutions, sometimes also building blocks, into an aviation product that were not born in aviation. So aviation for a long time has developed this mantra that it is the best engineering. So aerospace is the best engineering discipline you can think of, and the best solutions, be it mechanical or electronic or whatever, comes from aerospace. And I think the late 80s, 90s, 2000s have kind of showed the opposite of this, and we have incredible other industries, the medical side, even automotive sometimes, that have proven to be better at many things aviation traditionally has come to, just because they were operating at scale that allowed them to weed out all the issues very, very quickly. Yeah? So in aviation, let's say if you produce 1,000 parts of something, you will find out about issues associated to those 1,000 parts. So your sample base is limited. Whereas, I'll give an example, the Amazon's Echo Speaker is produced in the tens of millions, right? So they are able to weed out totally different failure modes and also face different challenges than aviation ever could reach in practice, right? So let's say the case of 1 in a million, 1 in a billion is art and a craft in aviation, but it's actually experiential. It's based on real experience in other industries. And, there's nothing better than solid proof for actually doing it. So now, because of the all electronics industry, the huge rise in everything mechatronic, let's say in the last 20 years, you definitely come to solutions which, in my view, are better than what aviation could do traditionally. So the exciting part for me is, how do you pull this into aviation? How do you show that aviation is compatible with that? And that you perhaps don't even have to re-engineer for aviation separately, that, there's ways of leveraging the collective human effort into inventing something. Mm-hmm. It's not applicable across the board, not at all, but it can be looked at from very different perspectives. And we were also here in the company successful utilizing non-aviation technology into our aircraft. And they have received the certifications from aviation authorities that are at the same level as things that were born in aviation for aviation. And they just show very good track records. So, and yeah, we have just an incredible team of very open-minded people who are not afraid of challenging the established.
Yeah. And what is that like being part of Pipistrel? I mean, you guys are challenging the status quo of what aviation can look like, what pilot training can look like, what gliding can look like even. And, you do have a wave of companies that I'm sure will be innovating in the space and trying to catch up. But I mean, as you mentioned, it takes time and it takes experience and it takes putting those products out there to actually get the feedback. Is that kind of where Pipistrel has the huge advantage on the industry? Is that the fact that you've been doing it kind of the longest?
It definitely helps if we'll be able to keep on riding this wave. So it's not something that's there for a given. There will be people who will be joining the effort, the trend. Some of them are closer than others. But the fact is, there's a big difference between inventing, innovating, and actually living from it. So Pipistrel's founder has said many times that it's great to be a pioneer. It's just incredibly hard to live from this. And if you're just continuing to be pioneering, it's not trivial. Then again, manufacturing is hard. It's hard to scale. So all of the magnitude of the complete challenge definitely is revealed only after product, even after its certification run, starts to go through its manufacturing challenges and then into the market. It's just connected to possibly the first few months of the product actually hitting the market in aviation. It will have flown more hours than ever before in a test campaign, and it will meet more different people with different mindset than ever before, right? So your assumptions in will people understand the design? How will they use it? Will they read instructions? It can come to these very benign things are put to the challenge. And we've gone over this hump. So we have these incredibly valuable lessons that we've learned in a hard way. I wouldn't say it was a terrible experience. I would do it again in a heartbeat, but yes, you do hit things for the first time, and sometimes it's not easy to have answers at hand. But Pipistrel, yes, we design. It's a Valley Selector is a good example. It's 100% designed and made in-house. Batteries, power controllers, engines, chargers. So it also gives us a very, let's say, real and validated perspective as to what we wish to continue keeping as core competence, such as batteries, and which elements of the aircraft for the future we may want to relinquish to other experts, such as cockpit displays and avionics, right? I mean, we're not the experts, but we had done it because we had to do it. Nobody else was out there willing to, but also it's good that initially you have the complete understanding of a very novel product. So it's like a one-stop shop, and it's valuable when you discuss with the authorities, when you discuss with your customer base.
Well, and also when it comes to innovation, you're able to know exactly what you need and what the capabilities can be and how far you can push a certain component or material or whatever that is.
Yeah, absolutely. I mean, it's the same if you look at cooking, like watching a TV channel as somebody else cook. Fine, it may seem easy and trivial, but then when you go do it, it might work out better or not. There's always some secret ingredient that they never show on TV, right? So you will never know the complete story from a book or somebody's storytelling. Only if you've done it yourself for the entirety of it, then you see the full picture. So this definitely is a privilege that we have here at Pipistrel, basically as a testament of this company's value of innovation driving success. There's not too many companies that basically have put their existence kind of a bit on the edge with every single new product introduction, right? So we were lucky that we were managing to do that, and we look forward to continue being sharp and innovating and defying the established, if you wish.
It's amazing. Do you remember, for you personally, your first consciously sustainable purchase you made where you said, I'm going to buy this product or do this thing because I want to be a little bit more conscious of how I'm living?
Yeah, absolutely. It might not seem as anything particular, but it was regular printing paper in college, right? So that my notes were printed on recycled paper rather than just the bleached white. That was like a super conscious decision. And at that time, it was 3 times the price, but I didn't care. And then, yes, there's many more. But if you ask me for the first time, it was recycled office paper, because that was basically what I went through lots of, being at college, and notes and iPads weren't there. I'm still from that generation. So hand scribbled notes were definitely a thing. So I was taking hand scribbled notes throughout college on recycled paper intentionally.
Oh, that's so cool. That is really cool. I think that might be actually one of the coolest ones, because I ask that question to every single guest, and I feel like that is probably one of the best answers I've ever heard. That's awesome.
To me, it's like, if I'm doing something intentionally, it's like, what's the lever you can pull for the greatest effect? You never can pull all, but for me as a student, paper was a big effect.
That was a big lever. Awesome. And then what is your favorite place to enjoy nature?
Somewhere lakeside, I would say. I like diversity. So Slovenia has many small alpine lakes. Water comforts me. Although I like flying, I'm a passionate aviator, but for some reason, maybe it's just the molecular content of a human body that wants to be next to other molecules of water. But I find it calming when I'm near, a body of water, a lake preferably. And whether that's overflying it or hiking next to it, or just putting my feet into it in the heat of the summer. I enjoy that.
I love that. And where can people get involved with Pipistrel, whether engage with you guys on social media or email you guys or even see one in person? Where does all that happen?
So Pipistrel has approximately 2,700 aircraft now across all continents. So you should not have too much trouble finding one. Look for very sleek aircraft, sleek wings, sleek fuselages. They're mostly white, small, and they're not noisy. So look carefully, because you won't hear them that pronounced as others. Otherwise, we are on all the typical social media. Look for our LinkedIn updates. We constantly post new jobs, especially this spring. We've had the most ever, and we are looking for very different profiles. And if you are enticed and you're interested in really making a difference in how we fly and what we fly with, join us. Consider checking out www.pipistrel-aircraft.com or our LinkedIn handles. Feel free to reach out either straight to us or any of the Pipistrel's distributors across the world. I'm sure that everybody will be happy to speak passionately about what we do, what we represent, and our continued journey of electrification of flight.
I love it. Tine, thank you for taking the time to hop on the podcast and dive through all these subjects. I think aviation is such an exciting thing. And if you think about it historically, it's always been a huge part of society when, it really came to full market. It was exciting. It was flight. That there's something so just empowering about it and freeing about it. Mm-hmm. And I think that you guys are on the right at the cutting edge of the new frontier of what flight will look like for the next generation.
Yeah, I think that there's not too many things out there in life which are so romantic and so technological at the same time. So aviation has really the power of touching many people's hearts in many different ways. But hey, isn't it time that we do it in a cautious and environmentally friendly way so that the next generations can look back and say, hey, this was the decisive moment in time where also aircraft started to be proper for the environment, proper for the future, and also proper for what they can bring in our travel patterns and how we fly and where we fly from. So maybe not having to take a long drive to the airport, but literally taking off from your neighborhood airfield and maybe connecting somewhere else, but actually going to and from where you really want to go, and not from where the airports happen to stand today. So I think that future for aviation is really exciting on the technical as well as societal front. Next decade is definitely the most exciting decade yet for aviation. I'm convinced about that.
I love it. Well, Tine, thank you so much for taking the time, and good luck to Pipistrel on everything you guys are working on.
You're welcome.
Thank you for listening to the Sustainable Goat podcast. I'm your host, Steve Cassingham. With each episode, we can further define what it means to create a truly sustainable and resilient future.
I think the new status is to show that you actually care. You want to drive change and you want to be part of a sustainable future.
People fight for what they love.
Let's really all target for a small but significant shift in the way we live, we consume, and we plan our life.
Join us at sustainablegoat.com.